Wait a minute. I'll check the charging. Later, charging problem is there. I don't know what suddenly class to close. Okay. Charging is on. Is voice clear? Voice clear? Everything okay? Okay, I'll start now. See, as I told, today due to some problem, my voice has slight problem. You can see there. It is not the usual because daytime I take around 4-5 hours class, some competitive examination class, and little weather problem also is there. Maybe little coldness is there. Slightly voice is not fully okay. What you can call, there's a name for that voice. Not husky voice, little problem. Manage with it. But you can make out. We started bending and shear stress distribution. I derived the basic equation with all the principle. Everything is told. Correctly we derived with no doubt at all. Strain variation, stress variation, and what is the real meaning of resisting moment, how BM resisted. I considered by an example of I section where I found the force in the upper flange, force in the web above the flange, above the neutral axis, resultant force I found, lower side did same thing. Then I found the two resultant C and T, lever arm A. I calculated the internal resisting couple, either C into A or T into A, and fortunately we got back the bending momentum. Yes or no? What fortunately? It has to come. Fortunately, we got back the bending momentum. I told at that time, if the answer is not coming, it is complete theory is wrong then. Yes, we got it. Same. There's a bore well going on, little far away. I think they are boring earth from here up to USA, I think. 2 days non-stop they are doing, still not stopped. Maybe from Indian side, they are piercing soil and going to go to what? American side. They may pierce the earth. It looks like that way. Tomorrow I'll ask them, what you are planning to go to other side by this route only, shortest route. Okay, now, then I stop the bending equation there. I have not explained the terms also much because I told RCC part, some important concept is there regarding moment of inertia. Basic bending theory, we write what? M by I equal to sigma by Y. Of course, in RCC you don't write sigma, you write F, that's all. Sigma or F by Y. In RCC, we don't use this equation. We consider resultant compression, resultant tension by force equal to stress into average stress into area, locate the line of action, then internal couple. We got the equation there. Not see here, your M equal to sigma into I by Y. But RCC, we got M equal to Bx Fc by 2. Fc is nothing but sigma only into D minus X by 3. Other equation is M equal to AST Ft Fst into D minus X by 3. Here I asked a question. Moment of inertia is not considered. You all agreed. Then I told it is considered without able to see it. We are not able to see it. Don't include me. I can see it. If I look there, I can see moment of inertia there. I can see moment of inertia there. Problem is what? People will ask, sir, where? There. Sir, no sir, it is not there. It is here, sir. I. See, here you can tell strength of materials I is there. There I is not there. It is there. If it is not there, this I will tell you why it happened. I don't want to disclose the place, etc. Some reputed place. I saw a class in the online, not now. I won't tell when. Some student asked a doubt. It is around 1.5 years earlier. During COVID time, he asked a doubt. Sir, in RCC, cannot we use basic bending equation? M by I equal to sigma by y. First answer came. Within no time, I do not want to tell where, who, etc. Sorry. If he is seeing the video, he will make out. Others may not make out. Answer came, no. You cannot use moment of inertia there. I felt pity for that. See, reputed place. He told, we cannot use moment of inertia there. RCC separate principle. What separate principle? Both are same. That's why I solved a question by strength of materials basis, RC question, and also I solved by RC equation. Now, I asked a question. See, here yesterday first solution, I calculated I. Okay, then people will tell, yes, moment of inertia used. Next I solved by using RC equation. Remember, everything is for working stress method. If it is by elastic theory, if it is limit state method, same format, coefficient will change. Instead of 0.3, you may get 0.4 or 0.15. That's all. By 2 is by 2. And into is into. D is D. X is X. By 3 is not by 3. Something else. Minus is minus. Breadth into distance into stress. Same there also. Nobody in the world can change it. So, anyway, that is modified version. There you cannot use strength of materials, but you can use strength of materials, but you have to go for more rigorous calculation. You can use it. Now, my question is I used or not? All of you told yesterday no. Then I told used. I told tell me where used. So far no answer came. People who are asking for brain teaser, answer it. Okay, now, then I asked you in the end of class yesterday, do you want to get this equation by considering moment of inertia? See, RCC what you do is compression area B into X, average stress FC plus 0 divided by 2. I can see everything. Bx FC by 2 is the compression force. D minus 1/3 X. Why? Resultant compression acts at all told yesterday. 1/3 of triangle, the 1/3 of that X. So lever arm is D minus X by 3. You got M. Other one, AST into FST, tension force in tension steel into lever arm, D minus X by 3. This we derived. Nowhere we used moment of inertia. So somebody answered that way. You cannot use moment of inertia. This is my reply for them. Those who tell moment of inertia cannot be used. It can be used. Now, so then I asked you, do you want or not? So many told, yes, we want it, please. Yes. See, my class is for information. Someone will tell, all these are not required. Leave the class. Don't come to my class. See, only one answer. I am teaching for giving thorough knowledge, not for time pass or exam oriented. So, such people, they need not come to the class. Who told you to come first of all? I may lose some views. I may lose what time. I may lose subscriber. No problem. But those who are serious, they will appreciate more. That's what I want. Okay, now, see the equations. I am removing it now. I will get these two equations now by strength of material concept using M by I equal to sigma by Y. Instead of sigma, I will use F. Okay. See the equation first. Removing now, this will once again appear. I will ask you, is it same as earlier? What I told? You should tell yes, same. You have to tell yes. Okay. Now, start. And one more thing. At the end of today's class, I will give one more information for you regarding section modulus in strength of materials and section modulus in RCC. Some will tell, same people, RCC, section modulus is not there. What not there? It is there. I will show it. And in strength of materials for rectangular section modulus is, if you remember, Z. BD is capital D. There is no question of small d, capital D here. You can tell BD square by, tell what? In rectangular section, strength of materials, no RC theory. Section modulus is, everybody know this one. BD square by, people know it. 6, correct. Today morning I took a class. I asked them, tell me section modulus. They are not knowing what is section modulus. When I told them, BD cube by, sir, 12. BD square by 6, sir. Why? Sir, it is, we by-hearted in B, in steel, and then in precious concrete, so many places, we used it, BD square by 6. They do not know what is section modulus. First of all, they don't know any meaning. Then I will ask, what is section modulus? Sir, I don't know. Then you told BD square by, sir, 6. Y means by-hearted. WL square by, they will tell 8. I will tell, who told I want for a fixed beam? Sir, then 12. No, I will tell 11 by 192. Partial UDL. Oh, sorry, sir. Or WL square by, I will tell 9 root 3. Triangle load. Don't commit to answer unless you hear the question properly. How much? You go to a shop, ask, how much? He will tell, how much for what? If a place is selling only one item, see, if a place is selling only one item, roadside, only dosa, you ask him, how much? He will tell 40 rupees because he knows you are asking dosa. If you go to a hotel and ask, how much? How much for what, sir? For what? Oh, see, how much means, so do not answer the question till question is completed. Remember, in my class also, do not comment unnecessarily, I will tell those, unless you know where you stand. Very sorry to tell. Sometimes people got having commenting or trying to find mistake in others. I won't tell the names all. I don't want to tell. They think that what they know too much. For them, my advice, do not comment that way unless you realize where you are and improve and you reach a level from where you can comment. Not simply little you are knowing and commenting. As if someone actually even challenged me also earlier. Can you solve it in 1 minute? I can solve in 1 second, I told him. Then tell me. I told I need not tell you. I need not tell you. Who are you to ask? Names all I will not tell because I saw those things. Nobody can tell me, then you show it. Why should I show it? If I want to show it, come in front of me. Have a discussion with me. Then realize. I will see that he will run away from there. Okay, start. Now, consider, today I will close all the RCC part and if the little time is there, I will stop. Next class onwards, back to real bending theory of some. So, those who are not interested in all these one, you see class number, I forgot now, 3 I think. From 3, jump to class number 8. Over. See. RC section, 1 minute. I should see how much visible, how much not visible. 1 minute. Because little camera is tilted. Yes, no problem I think. Okay, here. I should know the limit. Because do not want to write something and later tell not visible. Oh, furthermore, full, today I don't know, full space is there. Means upper lower side, there are some gaps are there. Okay. See, such show off I do not want. If I turn this one, I can see upper side, lower side, something is visible. No problem. People have not come to my class for show off. What dress I wear, or where dust is there, or in the board where you can see that mark. Leave it, don't see it. Okay, start. I won't see there now. Rectangular section of a RC beam. Remember now, I am indirectly telling where moment of inertia is used. Rectangular section of a singly reinforced RC beam. RC beam, 1 minute, bending moment M, let it be sagging. Why? Something you require, compression tension. Neutral is here, not leave it now. This is not neutral axis. And remember, working stress method, because based on elastic theory, we cannot go beyond the elastic limit or proportionality limit. See, start. Cross section is here. It won't take much time now. See, this is width B. People who tell moment of basic bending equation cannot be used for what? Cannot be used for RC. They will get the answer now. This is AST. Okay, I will put AST like this. This is effective cover. You write yourself only, effective cover. So this will become effective depth D. And then somewhere here, neutral axis. This distance I am calling X. If that is X, this distance will be D minus X. This is the area in compression. See, area in compression. This is the area in tension. This is ignored. And if it is AST, that AST equal to number of bars N into what? N number of bars, N number, say diameter equal to 5. Okay. N number of 5. Suppose it is 4 of 20 mm, AST equal to pi by 4 of 20 square into 4. Clear? Pi by 4 of 20 square into 4. That is not clear, means. See. Clear? Suddenly Borwell, they made sound. Why? He told, this why are you explaining? No, that is that other sound. It coincided. Sometimes it happens. When I tell repeatedly, they make the sound. And you already told it, don't tell once again. See, now, consider cross-section in terms of equivalent concrete. This all I already told you, not much now. See, compression taken by concrete. This is the area. This is B, this is X. X is red color because neutral axis. Okay, buddy. This is the area of concrete in compression. Somewhere here is AST. This AST is area of steel in tension steel. Therefore, tell me answer. This is what is the equivalent concrete area here. Equivalent concrete area equal to M times AST. I already told you where M stands for modular ratio. See, I have already told last time, so I won't repeat once again. You should study previous class. M modular ratio. This distance is D minus X. Okay. Now, start. Stress diagram, draw here. This is bending stress distribution diagram across cross section for equivalent concrete area. That is very important. Here, I told yesterday FCC maximum. Today I am going to RC symbol, I will call FC. FC means because maximum compressive stress in concrete. Stress in concrete. Here, this side, it is what? Stress in steel, in tension. But concrete I will write stress in equivalent concrete in tension, FEQCT, joined by a straight line, over, passes through neutral axis, compression, tension, over. This is for concrete. Okay, now start. Basic bending equation. Basic bending equation means people who tell we have from basic bending equation strength of materials, all people who told basic bending equation cannot be used for RCC, now see can be used or not. Let me see. M divided by I equal to, actually there you write sigma by y, here RCC I write F by y. F is the bend, F is bending stress at y from neutral axis. That y can be either this way, see, y can be either this way or this way. Or now that y and x are different. Okay, now start. M we want to find, F I will do later, I want. So before that one, what you do? First you require what is the value of x. I write here. X you can find by, x can be found by how? That is depth of neutral axis. Neutral axis from, don't tell top edge, from extreme compression edge. That is x, can be x. Depth, sometimes if you rub this way, it becomes more difficult. Depth of neutral axis from extreme compression edge. Compression edge. That is called x, can be found by equating moment of compression area of concrete to moment of equivalent concrete area for to replace tension steel about neutral axis. Why I am not writing? Because yesterday's class or earlier class I told it. So those who are serious, oh he told, oh let me go and check and write it. Little effort for you also. That will give you, see, I already told you, b into x by 2, bx into x by 2 equal to, this equivalent area is m times ast into d minus x, or the corresponding equation is, I will put red color, bx square by 2 equal to m times ast into d minus x. This is pure strength of materials. That instead of taking moment about the top edge, we take moment about neutral axis. Last time you know it. Both the way we got same answer. Yes or no? Last time. Both the way we got same answer. Remember it? Yes or no? Both the way we got same answer last time. Once you got y bar, once the equation, then I gave simplified form. Yes, therefore leave it now. Now start. Moment of inertia of cross section, I want. See, I about neutral axis for equivalent concrete area. Very important. Concrete area equal to, see, first I, see, people who will tell moment of inertia cannot be used. See now. First I about its own axis. That is bx cube by 12 plus area b into x. If this is not clear, you don't know engineering mechanics, moment of inertia into this distance square, x by 2 square plus, see here, n number of bars, see I told you, let it be n number of bars, where I wrote it? I wrote here, n number of bars of diameter 5. Therefore, pi by 64 into 5 power 4. Moment of inertia of See, there can be any number of bars. Imagine, so many bars are there. One of the bar, pi by 64 into 5 power 4 plus pi by 4 of 5 square is the area into from CG to here is d minus x whole square. Actually, already last time told you. This will give moment of inertia for one bar about neutral axis. There are n number of bars into n. This will give moment of inertia of n number of steel bars. I want to convert to equivalent concrete. Tell me, multiply by how much? I want to convert it to, because that is concrete. I want this also to be concrete. Multiply by, first, multiply by m. M. Now see, this number you can cut. Tell why? Why? Because it is so small. It is so small, means negligibly small. You can check later. Yesterday's calculation, I told you can cut this one. If you don't cut, if you cut, you may get 2 crore 60 lakhs 48,000 and 458 rupees. If you don't cut, if you cut, you will get 2 crores 60 lakh 48,150 rupees. Ayo, someone will tell 2 crore transaction, this 200, 300 rupees is, please leave it. Please leave it. Don't consider. Clear or not? If you want, you check it. This also I told you. Moment of inertia of a circle about its own axis can be ignored if the area is very, very far away. Strength of engineering mechanics, I told this principle regarding radius of gyration. See, the term radius of gyration, so powerful. People who are doing steel structures, they are using repeatedly. But with regret, I have to tell, majority does not know what is really meaning of radius of gyration. Yenadu, sir, root of I by A. Ayo, that is formula. Tell me what is the meaning of radius of gyration. They will tell Kannada, sir, gottilla, Hindi, pata nahi, English, I don't know. Then you told so much about it, sir, formula. Okay, see. Now, see correctly. Pi by 4 of 5 square is area of 1 bar into n. Tell what this will give you. Pi by 4 of 5 square into n, what it will give you? First, what it will give you? Pi by 4 of diameter square into number of bars, what it will give you? If you don't know, better not continue the class. Pi by 4 of diameter square, it will give you AST. AST. Therefore, the second term will become, see, this term can be replaced by what? Pi by 4 of, or you write once again, or equal to, see now, bx cube by 12 plus bx, x into x into x. This is bx cube by 12, this is bx cube by 4. 1 by 12 plus 1 by 4, I know it is 1 by 3. So it is bx cube by 3 plus m times this term. See, pi by 4 of 5 square into n is AST. M times AST into d minus x whole square is moment of inertia. Tell yes or no first. This is moment of inertia. So therefore, in RCC also, I am using now moment of inertia. Nobody uses it. If you see, I think nowhere you can get it. In case someone told earlier, I regret. Okay, I'll tell sorry. But as far as I know, I have never seen anywhere people using this I concept for RCC. You may tell, no sir, somebody used it. Good, he knows subject. I appreciate. But I have not seen. Okay, now, correctly now. Now, this I want to change. See now, see there. I told you, if I see earlier, I can see moment of inertia. Remember, Still I cannot see moment of inertia in that equation. It's slowly coming now. See, like in the YouTube or anywhere, sometime dull, slowly becomes clear that way. See, slowly I is coming. Yes. Now slowly I can see in the RCC, somewhere there, I is telling, I am also there. Good, I know it. Okay, start. Now, I will write I once again now. So, final result for I is what? I about neutral axis, bx cube by 12 plus m times ast into d minus x whole square. Now, I will write it in two different options. See, I will do one thing now. I will write this I in two different options. Either that way, I neutral axis, or this way. See, start. Bx cube by 12 equal to, I will write bx square by 2, x cube by 12 is x square by 2 into, tell me, how much of x? Fast. Bx cube by 12 is bx square by 2 into how much time of x? Fast. 3 by 3. 3 by 3. Bx cube by, it is bx cube by 3. Okay. Bx cube by 3 is how much times of bx square by 2 into 1 by 6. What is this one? 1 by 3 is 1 by 2 into. What is this mathematics? Where you learned mathematics from? First of all, 1 by 6. Abba, I really feel pity. 1 by 6. I should get back bx cube by 3. Abba, someone told correctly 2/3 of x. See, 2 will cancel. Answer. Plus what? MAST into d minus x whole square. Correct? Or I will do one thing. I will write here, not that way. I will write plus MAST into d minus x. See, this is one term. I will write bx square by 2. Here I write MAST into d minus x into d minus x. Tell me, correct? Correct or not? First. Correct or not? Is it correct now? Why do it? Yes, correct. Now, do one thing. You know that, see here, you know that, we know that bx square by 2 equal to m times ast into d minus x. Correct? This is the, for C neutral axis to coincide with CG. See here, already there. Now I will do one thing. Once I will replace this MAST into d minus x by bx square by 2. So, if I continue here, option one is your I equal to, see, bx square by 2 into 2/3 of x plus MAST into d minus x. I will once again write bx square by 2 into d minus x. No problem? Tell me. No problem? One option. Tell me. Any problem? You should tell no problem. Any problem is there or correct? Any problem or correct? No comment. Is there any problem or correct? See, if you don't answer, because I want to confirm no voice problem. Now, or equal to, I will take bx square by 2 outside. It becomes 2 by 3 of x plus d minus x. Or it is bx square by 2 into d minus 1 plus 2 by 3 is x by 3. Tell me, this is also correct? Minus 1 plus 2 by 3 is minus 1 by 3. Someone will tell, oh, d minus x by 3 came. Yes. where it will go in my class, how it can escape, it has to come. Fast. Okay, this is one of the option for I. Okay, so I will write one of the I option as bx square by 2 times what? D minus x by 3 is one of the option. Other option is, see, option 2. I write here now, option 2. Okay, start. Other option is, now I will replace bx square by 2 by what? I replace bx square by 2 by mast d minus x. So, other option of I is, earlier I told what? I replace this one by this one. Now I replace this one by that one. Or it is bx square by 2, I will put mast into d minus x into 2 by 3 of x plus once again mast into d minus x, or equal to, I will push mast outside. If I push mast outside, and also I will push what? I will push mast and also d minus x outside. What happens? It is 2 by 3x plus d minus x, or equal to mast into d minus x into d minus 1 plus 2 by 3 is minus 1 by 3 x by 3. So my other option of I about neutral axis is what? mast into d minus x into d minus x by 3 is my other option. Tell me, all these fully clear? If clear, my work is over. If fully clear, my work is over. If everything is clear, see, these all don't by heart. Understand and enjoy. When a concept such comes, you don't have to bother who is using it. But you should tell somebody, you can't use means you tell, don't tell that way. Unless you know the answer, do not tell something is wrong. Clear? Okay. Now, all over now, I will remove everything now. I will maintain only basic bending equation. Okay, start. I told these are the two options of I. Okay, now start. Consider m by I equal to f by y. Substitute f equal to fc, means what? Maximum compressive stress in concrete. Then tell me, what is your y? If I want stress equal to fc, when you tell m by I equal to f by y, when I want this stress, tell me, what is your y value? First, what is your y value? Y is the distance of the fiber from neutral axis. If I want this stress, y is measured from neutral axis. What is y equal to? Fast. If I consider the top fiber, that is compression edge, I put f equal to fc. Then what is y equal to? See there. What is y equal to? This per time, y equal to x. Start. Substitute. M divided by, for compression, I will use this equation. What? bx square by 2 into d minus x by 3 equal to stress is fc divided by x. Or this x and square will cancel. Or you get m equal to b. Go that side. B, x. You also go that side. X. Then I want fc first. fc. Then you come here. Divide by 2 into d minus x by 3. Oh. Right here. Oh. Is it the same answer or equation I got by RC theory? Tell me. There you did RC theory, lever arm, resultant force, etc. Here we used basic bending equation, we consider moment of inertia. Is the answer same as earlier? First, is this answer I wrote earlier? I told you, see those one. Is this result same as that result? Little fast. Yes. Therefore, my life is saved. Reputation at stake. Now it is saved. Good. Okay. One. Right here. Yes. Therefore, you tell anybody you cannot use moment of inertia concept for RCC means, for working test method means, you do not know subject. That's why you tell you cannot use. You can use, but RCC, we don't use this way. You go for transform section there and you consider force and lever arm and do it. But remember, even that also came from basic bending theory only. Tell me, fully clear? Then somebody will ask me, okay, compression, this is based on compression. You got it. What about tension? When compression came in tension, is it something special? I will tell tension. What? You are special. Now you also come. Tension. See, second one. 1 over. Once again consider M by I equal to F by Y. Now, M is M. I is I. I will use this I now. Why? Because tension I want. MAST into D minus X into D minus X by 3 equal to, tell the answer. I want to write stress equal to FEQC2. FEQCT means stress for equivalent concrete, stress for or tensile stress, or stress for equivalent concrete area in tension divided by, tell me now. Now my Y should be what? When I use that, when I consider that one, my Y should be X. Now tell me in the bracket, now when I put F equal to FEQCT, tell what should be my Y value? What should be my Y value? First, what should be my Y value? Y is distance from neutral axis. See there. Please answer fast. D minus X. D minus X. Now, D minus X gets cancelled. Or your M equal to, see here, go that side. MAST into FEQCT into D minus X by 3. But did I use M in the second equation earlier? I am getting little confusion now. Did I use M in the second equation there? Tell me part. I wrote M equal to BXFC by 2 into D minus X by 3. Which you got? Second I wrote AST into FST into D minus X by 3. Did I use M there? Did I use M when I wrote the answer in the beginning? I wrote earlier RCC, one equation, M equal to BXFC by 2 into D minus X by 3. That already came. Second I wrote, I remember, M equal to AST into FST into D minus X by 3. But M came. Was M there? Tell me. No. But is it here or not? M is not there in RCC. In the in the final expression for M based on tension, modular ratio was not there. There it is not there. But here it is there or not there. In the strength, in the RC theory, in the final expression for M based on tension, modular ratio was not there. But here, modular ratio is there or not there? There, not there. Here. There, not there. Here. There, not there. Here. It is there. Ayyo. If it is not there and if it is here, my complete reputation gone. Then I am going to close the class once for all. In future, I will not take the class. Different equation. I told principle. There M is not there. Here M is there means I have no moral right to continue 1 micromillimeter. So therefore, sorry. Oh, I should be, someone will suggest me, sir, ಕನ್ನಡದಲ್ಲಿ ಪಾಠ ಮಾಡೋಕ್ಕೆ ಮುಂಚೆ ತುಂಬ ಹೇಳೋಕ್ಕೆ ಮುಂಚೆ ಸ್ವಲ್ಪ ಥಿಂಕ್ ಮಾಡಿ बहुत बोलने से पहले थोड़ा सोच लीजिए बाद में गड़बड़ हो गया तो your reputation gone. But 1 minute, I am not going to close. I stop non-stop for 1 hour. Little voice problem. I want 5 minutes break. No problem. 5 minutes break. When I come from the break and ask you, you should tell there M is not there. Here also M is not there. I will go there. From there, using what? Using some supernatural power, I will fall this M. Hey, M, you come there. Don't stay in the board. I will tell, I will pull the M. M, you are unwanted here. Vanish or get out. Get out allow, vanish. When I come there, you should tell, yes, M is not there. Okay. No problem. 5 minutes break. For you to think 5 minutes. Okay or not? Okay. Think, start. Think. Think and comment. See, you should not tell in my class, that time it is that way, this time this way, that time divided by 2, this time divided by 3, that time x, this time x square, there k is not there, here k is there, my class is not there. Whatever there, same here. Absolutely. It is impossible that you will get a different equation. This M has to vanish now. Okay. You can comment and tell what happens next. Or you tell me, yes, this M will vanish, therefore what? This M will vanish, therefore what? This M will vanish, therefore what will happen? M will vanish, therefore you get back the RC equation only, so class can be continued. Okay, 5 minutes. You tell class can be continued. You can give your comment with reason. With reason comment it. Let me know how many are able to understand. I will tell it, don't worry. For that matter, I never got panic. Okay, start. Not a very, very difficult one. But what happens is, sometimes people become happy if when they see it. When I told earlier, see there M is not there. Here M is there. Me don't know. Some will celebrate. Why? Finally he got stuck somewhere. That celebration will be short-lived. Without that much knowing concept, I will not talk this way. Do you think I will talk this way without knowing the real concept? Okay, now remember, this is not your FST. This FEQCT is stress in equivalent concrete area. In equivalent concrete area. Okay, that will be equal to what? That will be equal to FST, that is the stress in steel in tension. Tell me, multiplied by M or divided by M? Now people will tell, sir, if you want to remove the M, what to do? Tell me. Now you will tell the answer. Why? Because you know the answer. Divide by M. Don't tell divide by M just because I want to remove that M. Because stress in concrete equal to steel stress by M, or stress in steel equal to stress in concrete into M, or therefore this is equal to M times AST into FEQCT divided by M. Correct? No. M times AST into what? FEQCT divided by FST by M into D minus X by 3. M will cancel, or you get M equal to AST into FST into D minus X by 3 is the answer. Now, are you fully agreeing? Moment of inertia concept, using moment of inertia also, RCC expressions can be derived. Tell fast. RCC expressions, but nobody will do this way. Nobody will do this way because why? That is simple approach. But even basic bending theory can be applied for RCC also, but you require using moment of inertia. Fully clear? Yes. Okay. Now, last part of this one. All over now. Nothing further. Now I am quitting RCC. But before quitting RCC, I want to tell one thing. Once again, brain teaser. Last part today. Real brain teaser. If anybody gives perfect answer in the YouTube, I will appreciate. See, for any question asked by me in the YouTube, you should not answer in my personal number. Personal number means I don't see it first of all. Or I may see and I will not answer it. Let the people know that you get the answer. See, small part. See, little later we get. Consider a rectangular section. Rectangular section. Say B by what? B by D. See there. This is not RCC. Not RCC of just any material like steel or timber, not composite. Only one material. Only one material. One material. We know that M by I equal to, I will put F by Y now. Why? Because RCC I am using F. Tomorrow onwards, next class onwards, I will go to sigma. Only today F by Y. Or M divided by, I think I don't have to explain this one. If this is B, overall is D, there is no effective depth here. Neutral axis comes here. Each of them is D by 2, D by 2. Stress diagram will become like this. Correct? Both are equal. Now, or this is your FC maximum. If the BM is sagging, this is your FT maximum. Okay. I will tell FC maximum now. That the BM is sagging. M by I equal to, or you can tell M equal to I by Y into F, or you can tell M equal to F into Z, yes or no, where Z is called section modulus. Section modulus equal to I divided by Y corresponding to extreme fiber. I equal to BD cube by 12. Y equal to D by 2. Therefore, your Z for rectangular section of only one material, not RCC, equal to BD cube by 12 divided by D by 2. Or your Z will be equal to, tell the answer, people know this answer, BD square by, for rectangular section, Z equal to BD square by, BD square by, over, closing part. My question will come now, 6, over. Therefore, see, therefore, for a rectangular section of only one material, I will do one thing now. This FC maximum, I will tell F only. I will tell F only now. I will tell only F. Okay. Or 1 minute. Okay. I will go for FC. I will go for only FC maximum. Okay. Only one material and no effective depth. Your M equal to what? F into what? Z. Where Z equal to BD square by 6. Or you can write M equal to F into BD square by 6. Correct or wrong? First tell me. Correct or wrong? M equal to F into BD square by 6. Is the equation correct? See, people who want to brainstorming or brain teaser, answer the question now. Yes. Now, I will come to RCC. See, in RCC, capital D is not used. Tell what is used. Okay, I will leave that one now. Come to RCC. Sagging BM, once again. This is the cross section. Somewhere here is neutral axis. This is called X. This is called B. This is called AST, tension side, not required for me. Tension side, start. Here, your M equal to RCC, come to RCC. M equal to BX F by 2, FC by 2. BX FC by 2 into D minus X by 3. Tell me, yes or no? Fast. Already derived. Correct? Almost closing now. Now, again, some people will tell, section modulus theory is not used in RCC. It is not applicable to RCC. I will tell, why not applicable? No, sir, it is not applicable. Not applicable. I will show it is applicable. Wait 1 minute. Now, see, now consider, for understanding, consider a balanced section. See, consider a balanced section. 1 minute now, balanced section. If it is a balanced section, you working stress method. Remember now, very sorry, I cannot tell too much RCC. I talked about this balanced section in RCC for RCC batch 3-4 classes. Whereas for ETAP batch, maybe 1 or 2 class. So here, I cannot talk about RCC more. What I tell you, believe. For balance section, your FC will be sigma CBC. That is called, where you want to find moment of resistance for a balance section. Then FC becomes sigma CBC, permissible stress in concrete in bending compression. And your X equal to KD, where K equal to what? It becomes 280 divided by 280 plus 3 times sigma ST and X over. Then D minus X by 3, that is actually called what? Lever arm. For a balance section, lever arm is taken as JD or Shear. X equal to KD. Depth of neutral axis is a part of D. X is a part of D. Suppose it come to center. Tell X equal to. Suppose X come to center of D. Tell X equal. Then tell K equal to. See, you write X equal to K into D, a part of D. Suppose this come to center of this one for a D. Tell K equal to. Tell K equal to. It's a constant. If the neutral axis comes to exactly center, K equal to. Fast answer. K equal to 0.5. Okay. Now see, lever arm, that is A equal to D minus X by 3 or equal to D minus KD by 3 or equal to D into 1 minus K by 3. The term, this K is called, those who want write. But remember, don't write too much. Why? Then they will tell learning RCC. No. I am not going further in RCC. I am only showing the people that don't tell wrong things. See, this is called neutral axis constant for a balanced section. Here you can write this as JD. JD, in the JD, I take J. This is, see, this K is called neutral axis constant for balanced section. I can talk about under reinforce, over reinforce also. No. This is not RCC class. Better balanced. Somebody will ask, what is balanced section? Study RCC. JD. J is called lever arm constant for balanced section. Tell me, those who came to my RCC class, not ETAP people. ETAP people are not told working test method. Those who came to my RCC class, do you remember all this? Those who came to my RCC class, do you remember all this? At least, if anybody is there. Nobody. One person is there, not answering. Those who came to my RCC class, either offline or online, do you remember all this? One answer, fast. If you tell yes, I will continue. It is yes only. Why? Without this, I won't talk RCC. Okay, no answer. See, if you don't answer, problem comes. I get doubt. Any voice problem is there. If you tell yes means I get confidence. If you tell yes means I get confidence. Everything is okay. That is just to get two reasons. One, to know that you heard of this one. Second one, what? My voice is audible fully. Answer fast. Don't do like last time ETAP class, last Sunday. One class wasted there. I will talk about it tomorrow. One class, 4.5 hour class wasted. I felt so bad, but got frustrated there and stopped the class. 10-11 minutes I was shouting. No reply. Someone told maybe class started earlier. No. Class was started 6 minutes later only. See? Again no answer. If you don't answer, maybe you don't require the concept. If you don't answer, it means you don't require the concept. When you don't require the concept, why should I shout? Then I won't ask the question. I will curtail the class with the Z concept is cancelled. At least if you tell yes. Any voice problem? Is there any voice problem? Yes. After half an hour someone told, I remember. Okay. Now, see. Therefore, your moment of resistance for balance section for singly reinforced rectangular section in RCC working stress method is what? Is B into X equal to KD into sigma CBC by 2 into bracket D minus x by 3 is JD, or your MR there equal to, see here, B into D becomes what? BD square into, usually people call Q. That Q is called MR constant for balance section. Okay, start. Now, leave it as it is. So therefore, remember, in RCC also, Z will come. Yes or no? Nodi, their BD square, 6 you leave it. 6 only is the brain teaser. That 6 only is brain teaser. Those who think they know too much, now tell the answer. See, QBD square, here BD square by 6. Correct? Okay, now back to RCC. See, I write here now. Now back to sum. As per strength of materials, rectangular section of only one material, I told M equal to Fz, so your moment of resistance equal to F permissible. It is F permissible into Z. In RCC, MR equal to, see here, MR equal to, I will do one thing now, I will go for some other way now. It is, don't Q, once again go further. I will use original equation. It is sigma CBC into what? K into J divided by 2. See here, B into BD square. Here it is F permissible into BD square by 6. BD square by 6. Here it is, or you can tell sigma CBC into BD square into what? Or if I want BD square by what? Tell me. It is sigma CBC into BD square by 2 divided by Kj. Correct? 2 divided by Kj. Is it correct? 2 divided by Kj. 2 divided by Kj. Correct or not? If I put the full format, I want same format. See, there this is permissible stress. RCC also, this is permissible stress. Oh, in both the places, one number is permissible stress. Tell yes or no. In both the places, when you tell MR, it is, or I'll write here now. See, in both the places, MR, both the places, that is strength of materials for, in both the cases. What both case I told you? You write here, strength of materials where section is of only one material, no RCC, MR equal to what? It is permissible stress into Z. Z is section modulus. That Z equal to BD square by 6. In RCC, this is usual strength of materials or one material. RCC, MR equal to, once again, this is permissible stress only. It is permissible stress into, I will put once again Z. Z for RC section. Where Z equal to, where is the formula? Where I wrote? I forgot all this one. It is 2 divided by Z equal to, once again what? See, it is BD square. There capital D, here small d. That is, you know the reason. Why? There capital D because full depth effective. Here small d because you consider up to only CG of the steel. That is not a problem. Once again, BD square by not 6 by a number n. number n, a number or constant, by a number or constant. I'll put number. That number or constant equal to 2 divided by kj. Yes or no? 2 divided by kj. Everything correct? See there, any mistake is there? Most probably correct. Okay, now, therefore, here also Z principle comes. Why not BD square by 6? Because here, upper side, one side compression rectangle, other side tension steel equivalent. So, disturbance will come. Now, just to understand purpose, see. Suppose it is M20 better. Suppose you are using tar steel of grade FE41 or FE500, popular steel. I know that K will come approximately, exact value I will put you. K, I know it. You don't answer. Don't ask me how to get it. RCC, I know little RCC also. Okay, 280. 275. K will come 0.253. 25333. Your J will come 2533339. J will come 0.915535. Therefore, in that case, that number will come 2 divided by 0.25 into 0.915535. That will come 2 divided by 0.25 equal to divided by 0.915535 equal to 8.738. If any mistake is there, you correct it. If any mistake is there, correct it. In case any mistake is there, half into 0.29 into 0.9 equal to reciprocal equal to 7 point. Okay. If any mistake is there, correct it. Okay. Now my question, that is brain teaser. See, now people who, okay, class over now. What I want to prove, in strength of materials, we got width into depth square. In RCC also, we got width into depth square. Remember, in biaxial bending of column, for axial load, we consider PU by FCK BD. For bending, you consider MU by FCK BD square. Remember, you consider MU by FCK BD square. Tell yes or no. RCC column design. Remember it? MU by FCK BD square. So people who tell section modulus theory is not there, they do not know subject. Okay. Now, one beautiful brain teaser. Rectangular section in strength of materials. Strength of materials means ordinary section with the only one material. Your Z equal to BD square by 6. In RCC, if I use tar steel of grade FE500, then your K is 0.25339, your J equal to 0.915535, your Z will come BD square by 8.738. Okay, now, and also by chance, if your K is, for example, K is more than 0.5, just imagine. Yes, for mild steel, K comes to 0.53. Now it is not used. Say, K more than 0.5. Say, for example, 0.53. That is for mild steel. No, not 0.53. No, not more than 0.5. Or imagine, K is more than 0.5. It is possible. Very low strength of steel, 280 by 280 plus, yes, it is possible. I have to put a very, 0.53 comes in limit state method. Okay, I will put a very, very weak steel. Okay, nobody can tell. Some particular value of sigma weak steel, I will get K more than 0.5. 1 minute. Yes, you can get it. 280 by 280 into 3 into 0.1. Okay. I'll just check it now. It will come. 280 divided by bracket 280 plus 3 into 50. Yes, it can come more than 0.5. How much not required? If K is more than 0.5, then J equal to 1 minus K by 3 is 1 minus what? Or you do one thing, take K equal to 0.5 only. K equal to 0.5. If K equal to 0.5, tell why? Then neutral axis will correctly come to center. Yes or no? Neutral axis as 0.5 is better. If K is 0.5, if this is D, neutral axis comes to correctly here. 0.5D. Correct? Yes or no? If K equal to 0.5, neutral axis comes exactly center. That is same as rectangular section. Yes or no? Of course, the remaining portion is removed here. Only D considered. See, if the K equal to 0.5, neutral axis come to exactly center of D, then your J will be equal to 1 minus 0.5 by 3. 1 minus 0.5 by 3 is 0.83333. In that case, your MR will become, where is the answer? That constant will become, that constant number or N number will become, where is the formula? 2 divided by 0.5 divided by 0.833. Answer. 2 divided by 0.5 divided by 0.833 equal to 4.8. Correct? Okay. Now, my brain teaser question. Those who want to answer can answer now. See, I write here now. Everything I am removing. 4.8. ಎಷ್ಟು ಬಂತದ ಆನ್ಸರ್? ಇನ್ನೊಂದು? Oh, first answer I forgot now. I can do once again. 8.78. See, strength of material. Only one material. No composite. Z equal to BD square by 6. Now, RCC. When I used tar steel of grade FE 500, where your K is 0.25339, I got Z equal to BD square by 8.738. Whereas same in RCC, if by chance K equal to 0.5, then which steel I don't want, some steel K equal to 0.5, then my Z will come BD square by 4.8. Oh, now those who want to answer the question can answer. Here 1 by 6. Over. I am closing now. Here 1 by 6. Here 1 by 8.738. Here 1 by 4.8. Therefore, if I use tar of grade FE 500 with 0.2533 in K value, my Z is what? Lesser than rectangular section. This is lesser than rectangular section. But this is more than rectangular section. Question clear? One RCC in one example, my Z came, see, when it is 8 point something, it is less than 6. Why? It is divided by, it is 1 by 6. This is 1 by 8 point something. So, standard for rectangle is 1 by 6. When I used RCC for working test method, when I used FE 500 steel, I got Z BD square by 8.738. That is less than that for rectangular section of one material. Whereas if I use some other steel, where if K is 0.5, then my Z came BD square by 6 by 4.8, it became more than rectangular section. Question, why it came lesser, why it came more? Perfect logic. Those who are serious, of course, really you have to think. You have to really think. If you think, you may get the answer. But tell the answer in YouTube only. Do not tell anything in personal message number. YouTube answer. I will wait for the answer. Of course, this is not an enjoyable brain teaser. What I will ask later brain teasers are enjoyable, because this some will tell, sir, these are all we never came to know. Okay, leave it. This is for, because today I have closing RCC information here. I thought, let me tell this one. But don't be serious now. Real brain teaser I am asking is beautiful. I will ask, sigma m, how you can use second time? Or just to left, just to right, I already told you in the class number 100 somewhere. That way, so many are there where people know it, still don't know it. Okay. Now, we will meet in next class. Over now. Now, I will not discuss RCC in this class. I will continue from class number 3, I think. We will enter perfectly strength of materials part of basic bending equation. Okay, start. Now, these all will not come. Waiting for the answer. And nobody should tell in future, moment of inertia cannot be used in RCC, or section modulus cannot be used. It can be used, but with the proper knowledge. That's all. Okay, thank you.